Elemental Alchemist, a generative interface for semantic control of particle systems across dynamic levels of abstraction. Editing particle system visual effects is important for digital storytelling, but achieving controllable, art-directable results remains challenging. It requires users to manually translate high-level design goals into low-level parameter adjustments tailored to a 3D scene. To address this challenge, we introduce Elemental Alchemist. It leverages generative interfaces to transform these design goals, whether they are concrete or abstract, into scene-aware controls for semantic editing. It works as follows. For a given 3D scene, the system initializes a relevant particle system effect from a set of templates. The system then generates the contextual brush palette with brush tools tailored to the scene and the particle effect. Users can express their intentions through either sketching with the brush or typing a text prompt. There can be specific commands like moving the fire to the logs to make a bonfire or sketching a wind gust over the fire. The system then presents the generated control panel on the right, which has controls based on the user's intentions at different levels of abstraction. At higher levels, users see semantic options going from calm to strong gusts of wind, while at the lower level, they can directly adjust technical parameters such as X, Y, and Z axis forces. Both the brush palette and the control panel adapt to the scene, for instance, offering tools to increase the height of a fountain or expand the radius of a firework. Users may also introduce their own custom tools when needed. Users can also express high-level conceptual intentions, like making a fire look angry. The system then breaks these down into concepts and attributes, which are mapped to technical low-level controls. For example, a request to make the fire look angry is broken down into semantic concepts such as intensity and fierce appearance, which are further decomposed into attributes like rapid movement, high energy, vivid colors, and dynamic size. These in turn map to low-level parameters. For instance, rapid movement maps to velocity radius and velocity theta. Elemental Alchemist supports a variety of particle systems, from fire and water to magical effects. We evaluated the system through 3 tasks, covering different types of particle systems and tasks. In a guided task, participants made a fire look angry and directed it towards a tent. In a recreation task, participants recreated a water fountain effect to make it spurt water intermittently onto farmland around it. In an exploratory task, participants were given an option to choose from a set of animated superheroes and were asked to design a trailing special effect for them. We found participants use this system intuitively, for example, by using the brush to handwrite or sketch a scale to express their intent. Participants valued translating high-level creative goals into particle system parameters. For example, one participant semantically edited a fountain to make it look juicy. Another directed the particle system flowing from a superhero's hand to look like fire, while another made it look like snow falling from their hand. In each case, the system generated relevant tools and controls that allowed the creative intentions to come to life. We envision Elemental Alchemist as a complementary technique that can coexist with existing particle system tools. Overall, Elemental Alchemist supports semantic control of particle systems by combining contextual tool generation, intent-to-control mapping, and synchronized levels of abstraction to bridge creative intent and technical control.